Welcome to another deep dive. I'm always excited to see what our listeners bring to the table, and this time you guys have really outdone yourselves. Gliding.
Oh, yeah.
This is a whole new world for me. I mean, we've talked about powered flights so much on the show, and I thought I had a pretty good grasp of, the basics. But gliding, it's a whole different animal, isn't it?
Oh, absolutely. I mean, in a powered aircraft, you've got that engine there, right? So if you get into a little bit of trouble, you can always add power, climb out of it. But with gliding,
You're at the mercy of the elements.
you're at the mercy of the elements, exactly. Which is why the stuff you've sent in about safe ground operations, pre-flight procedures, it's absolutely fascinating and it's so important. I mean, getting it right on the ground is everything in gliding.
It seems like there's this, real emphasis on meticulousness, on attention to detail that goes way beyond what we normally talk about with powered flight. So what we're going to do in this deep dive is really unpack all of that. We're going to extract the crucial information for anyone working with gliders, from the moment they're taken out of storage to the point where they're ready for launch.
And what's great is your sources really span the spectrum. We've got technical manuals, personal accounts from experienced pilots, even some historical perspectives on how these practices have evolved over time.
Right. And I think that's what makes this so valuable for our listeners. Whether you're a seasoned glider pilot or you're just curious about this unique form of aviation, there's something here for everyone. We know we've got a real mix of expertise listening in, so we'll keep it clear, engaging, cut through the jargon wherever we can.
Practical takeaways.
Practical takeaways, that's what we're going for. So, where do we begin? I guess the logical starting point would be assembly and storage, right? Because these gliders, they don't just magically appear ready to fly. There's a whole process involved in getting them put together and making sure they're stored safely.
And that starts even before you start putting pieces together. Your sources, they really stress the importance of those initial considerations. Like even something as simple as choosing the right location for assembly.
Right, because you need space.
You need enough clear space. You don't
Yeah.
want to be bumping wings into things or having any kind of obstruction. And then the manpower, right. I mean, it's not a one-person job.
Oh, definitely not.
Right.
In fact, most of the manuals we looked at, they specify exactly how many people you need, depending on the glider type.
Yeah, that's crucial. And having the right tools, having them organized. It's almost like surgery in some ways.
It's like a well-choreographed dance.
Exactly. You don't want to be halfway through the process and then realize, oh, wait, where's that specific wrench?
And one thing that jumped out at me, that the need for a really thorough inventory before you even begin, making sure all the parts are there. Because I imagine if you're missing something crucial,
Well, that could be a real problem down the line.
it could be a disaster waiting to happen.
And then there's the checklists. The sources you sent, they hammer this point home.
Checklist, checklist, checklist.
Yeah, I mean, ideally, your GFMPOH, your glider flight manual, or your pilot's operating handbook, it'll have a dedicated assembly checklist. But if it doesn't, you absolutely have to create one.
And use it religiously every single time. No exceptions.
No exceptions. And this isn't just about, ticking boxes.
Yeah.
It's about minimizing distractions.
Yeah, because when you're putting a glider together, you need to be totally focused.
100%. No multitasking, no phone calls, no distractions.
And of course, before you even think about taking to the skies, you need to make sure you've got all your ducks in a row, documentation-wise.
Oh, paperwork. Can't forget the paperwork.
The airworthiness certificate needs to be displayed, your registration, all the required placards, and of course, the GFMPOH itself needs to be on board.
Absolutely. It's the glider's identity card and its operating instructions all rolled into one. Now, one thing that really struck me in your research was the emphasis on how to manage your tools and your hardware during the assembly process.
Yeah, and it's funny because, at first I thought, okay, this is really getting into the weeds. But then when you actually stop and think about it, it makes so much sense. The idea of using a dedicated shelf or even like a canvas with designated spots for each piece of hardware.
It seems so simple, right? But it's about preventing FOD, foreign object debris. Because even a tiny little washer, if it ends up in the wrong place, it can jam a control surface.
And then you're talking about a potentially catastrophic situation.
Absolutely. And that's why taking that extra moment to do a hardware inventory after you're done assembling, that's a simple but really effective way to double check that everything is where it should be.
And the sources were really interesting about the whole thing with tape. Like, you wouldn't think that a piece of tape could be a big deal, but apparently if it gets detached, especially in certain areas like the wing roots or the elevator, it can really mess with the aerodynamics.
It can cause control problems in flight.
Yeah, so even those seemingly small things, they can have huge consequences.
It's the attention to detail that matters.
So the assembly itself, we talked about needing multiple people depending on the glider type. But after all that work putting everything together, you can't just assume it's all good, right? You need some kind of verification process.
Absolutely. A thorough, meticulous inspection of every single attachment point, every bolt, every pin, making sure it's not only in place, but also properly secured and torqued to the correct specifications.
No shortcuts.
No shortcuts. And, speaking of space, we can't forget about storage, right? Because these gliders, they have these amazingly long wingspans, much wider than your typical hangar.
I mean, some of these wingspans, they're wider than a school bus. So detaching those wings or folding them in some cases, it seems to be pretty common practice.
Right. And if we think about it in terms of airfield infrastructure, hangar space is often at a premium. Hangars are often built with more traditional powered aircraft in mind.
Hmm.
So you might have a hangar that's, say, 35 to 45 feet wide.
But a glider with a wingspan of over 40 feet, that's not going to fit.
Not easily. So detaching or folding those wings becomes a necessity for a lot of glider owners just to be able to store them safely and efficiently.
Okay, and we're back to checklists again, which, at this point, I think we're starting to see a pattern here. We've got the critical assembly checklist, the CRAT, and the positive control check, the PCC.
Yeah, the CASI and the PCC, yeah.
And even if someone else completed the CAC, it sounds like it's the pilot's responsibility to still perform that PCC, which to me, that speaks volumes about personal responsibility. You're not just trusting someone else's work. You're taking ownership of that aircraft's safety.
It's like a final sign-off. It's that added layer of security, right? You're verifying everything yourself. And the sources you shared, they really recommend that pilots always refer to a written checklist, ideally from the manufacturer, right?
Yeah.
The GFMPOH.
Right, because that's going to be the most accurate and up-to-date information. Okay, moving on. Let's talk about getting these gliders from point A to point B. We're talking trailering, right? Because they're not exactly driving themselves down the road.
Oh yeah, trailering. Specialized trailers designed to cradle those delicate components, keeping them safe from bumps and scrapes during transport and storage. They often have special compartments for securing all the parts. It's almost like a mobile workshop for a glider.
Like a custom-built transport system.
Exactly. Yeah. And it's worth remembering that all the standard towing precautions still apply, right?
Right.
You're dealing with extra length, extra weight, so wider turns, longer braking distances, all of that needs to be factored in.
Now let's fast forward a bit. You've arrived at the airfield, the glider's off the trailer, but it's not in the air yet. So what about tying down and securing it properly?
Well, think about a busy airport environment, right? Propeller blast from powered aircraft, it can cause some serious damage to an unsecured glider.
Yeah, you definitely don't want to be anywhere near one of those when the engine spools up.
So closing and latching that canopy, that's the first step, always. And ideally, you want to position the glider facing directly into the wind, if possible. That helps to minimize stress on the structure.
Makes sense. And I noticed that some of the airfields have permanent tie-down points, but it sounds like those might not always be enough, especially if the wind conditions change.
Yeah, those permanent tie-downs, they might not have the adjustability you need to really batten things down in strong or gusty winds, which is why a lot of the sources recommend carrying your own tie-down kit, especially if you're doing cross-country flights.
So you're always prepared.
Exactly. Always prepared. And again, your DFMPOH, it's your best friend here. It should have specific guidelines on the best tie-down methods for your particular glider.
Now, for those really strong winds, I saw some interesting techniques mentioned, like tying the spoilers open or even using a padded tail stand.
Those are all about reducing the glider's profile, making it less susceptible to those strong gusts. Tying the spoilers open, it creates drag. It makes it harder for the wind to generate lift. And the padded tail stand. That helps to lower the wing's angle of attack, which further reduces the chance of the wind getting underneath and lifting the glider.
It's all about aerodynamics.
It's all about cheating the wind, essentially.
Okay, what about when a glider is being stored outside for a longer period of time? I imagine you need some extra protection then.
Oh yeah, definitely. Gust locks are essential. They prevent the control surfaces, your ailerons, elevator rudder from flapping around to the wind and potentially getting damaged. And you want to use covers too. Not just for the canopy to protect it from the elements and UV damage, but also for those small but important openings.
Like the pitot tube.
Like the pitot tube, the total energy probe, even the static ports.
Why the static ports? What are those for?
They're crucial for your instruments. They provide the reference air pressure for things like your altimeter and your airspeed indicator. If those get clogged, you're going to have inaccurate readings, which is obviously not a good thing.
Yeah, that could be a real problem in the air.
Absolutely. Now, another interesting point that came up was water ballast.
Water ballast. That sounds kind of counterintuitive. Why would you want to add weight to a glider?
Well, it's actually a performance thing, but it's also something you need to be really careful about, especially in colder climates.
Because of freezing.
Exactly. Water expands when it freezes, right? And if you've got water ballast in the tanks and it freezes, it can cause serious damage. So the rule of thumb is always drain the ballast before transporting the glider, or if there's any chance of freezing temperatures.
And if you can't drain it for some reason,
Then you can add antifreeze, the same stuff you'd use in your car. That'll prevent the water from freezing and expanding, and it'll protect the tanks.
okay, that makes sense. Now let's talk about getting these gliders around on the ground handling. It seems like there's a real art to it, especially when you're dealing with larger gliders and potentially windy conditions.
You got it. Ground handling is a team effort. It's all about careful coordination, clear communication, and it starts even before you start moving the glider. You need to brief everyone involved on the procedures.
Any hand signals you might be using.
Any hand signals, anything that's going to help everyone stay on the same page. Now, if you're using a vehicle to tow the glider, there are some specific rules of thumb to keep in mind, like the length of the tow line. It needs to be longer than half the wingspan.
Why is that so important?
Well, think about it. If one wingtip happens to snag on something or stop suddenly, that extra length in the tow line, it prevents the glider from pivoting sharply and potentially colliding with the tow vehicle.
Oh, right, because it's kind of like a pivot point.
Exactly. It's a safety buffer.
Yeah.
And always, always keep that canopy closed and latched during towing.
Piece of the wind.
Yeah, you don't want it to suddenly fly open and get damaged, or worse, cause some kind of control issue. And the whole process should be nice and smooth.
No sudden movements.
No sudden movements, exactly. You want to take up the slack in the tow rope gently, no jerking, no sudden acceleration. Keep it slow, keep it steady, walking speed at most.
And having at least one wing walker.
Oh, absolutely. At least one wing walker, and sometimes even more, depending on the size of the glider and the wind conditions. It's really a team effort, right? The driver of the tow vehicle and the wing walkers, they need to be constantly communicating, watching out for obstacles, monitoring the wind, and responding to each other's signals.
It's like a well-oiled machine.
Exactly.
Yeah.
Everyone has their role to play. Now, if you're dealing with high winds, things get even more hands-on, literally. You often need multiple people holding onto those wingtips, and the pilot actually uses the controls in the cockpit to help keep things stable.
So it's a real balancing act.
It is. And the pilot can use the spoilers, those panels that extend from the top of the wings, to disrupt the airflow and help keep those wings down.
And I noticed there are also some specialized towing aids. Things like trailer tow bars, which apparently attach directly to the towing vehicle and the glider.
Those can be really helpful, yeah. They provide more direct steering control over the glider, making it easier to guide, and it frees up the wing walkers to focus on clearances and potential hazards rather than having to worry about steering the glider. Okay, so we've got the glider assembled, we've got it tied down, we've moved it around on the ground. Now let's talk about actually getting it into the air. And that means we need to talk about tow ropes and tow hooks.
Because that's the connection between the glider and the tow plane, right?
That's the lifeline. And the strength of those tow ropes, it's not something you want to mess around with. There are very specific regulations in place to ensure that they're up to the task. Now, it's interesting because while the glider pilot is the one who's going to be inspecting that rope, the legal responsibility actually rests with the person operating the tow plane.
Really?
Yeah, they're the ones ultimately responsible for making sure that rope meets the required standards. And those inspections, they have to be meticulous every single time, looking for excessive wear, broken strands, any knots. Because a knot in a rope, it can actually reduce its strength by up to 50%.
Wow. And the area around the ring where it attaches to the rope, that's another critical spot to check.
Yeah, because that's where a lot of the wear and tear tends to concentrate. Now, these ropes, they're not indestructible, right? UV exposure, the number of tows, all these factors can degrade the material over time.
So they need to be replaced periodically.
Exactly. And it's interesting, the different materials they use, nylon, different types of polyester, polypropylene, Dacron, even steel in some specialized cases. The material really affects the rope's strength, its elasticity, and how well it resists things like UV degradation.
So it's not just a one-size-fits-all kind of thing.
Not at all. And the regulations, they specify that the tow line's braking strength has to fall within a certain range, usually 80 to 200% of the glider's maximum certificated weight.
Right. And that makes sense because you need it to be strong enough to handle the forces of launch, but not so strong that it could damage the glider if something goes wrong.
And your GFMPOH might have even more stringent requirements, so that's always the first place to check. Now, there's also this interesting concept of safety or weak links, which comes into play if the tow rope is significantly stronger than that allowed range.
How does that work?
So, if the braking strength of the tow rope is more than twice the glider's maximum weight, you have to install two safety weak links, one at the glider end of the rope and one at the tow plane end.
So they're deliberately weaker than the main rope.
Exactly. They're designed to brake predictably under excessive tension. And that helps to prevent structural damage to either the glider or the tow plane during launch. The weak link at the glider end has to have a braking strength within that 80 to 200% range of the glider's maximum weight. The weak link at the tow plane end needs to be stronger than the glider end link, but not more than 25% stronger, and it can't exceed twice the glider's maximum weight. It's all carefully calculated to protect both aircraft.
Wow, so even the failure points are engineered.
Exactly. They're part of the safety system.
Mm-hmm.
Now, when it comes to actually connecting the tow rope to the glider, there are a couple of common types of tow hooks. You've got the Schweitzer hook, which is an over-the-top design, and the Toast hook, which is a grasping mechanism. And regardless of which type your glider uses, it's crucial to inspect that hook thoroughly before every flight.
Looking for damage, making sure it operates smoothly.
Right. You want to make sure it locks securely and releases cleanly when it needs to. Okay, so the glider is assembled, the tow rope is checked, the hook is good to go. Now we come to one of the most important parts of the whole pre-flight process, the glider pre-flight inspection itself.
And this seems like it's even more in-depth than your typical pre-flight for a powered aircraft.
It is. It has to be. Because in a glider, you don't have that engine to rely on. Every single system has to be working perfectly. So the pre-flight, it covers every inch of that aircraft. And if your GFMPOH doesn't have a detailed checklist, you need to develop one yourself based on the guidelines and best practices.
And it really is comprehensive. Checking the overall condition of the fiberglass or fabric skin, making sure the canopy is clean and undamaged, verifying all the internal connections, checking the battery if the glider has one. It's a lot to take in.
You're right. And it's organized. It's not just randomly looking around. You're checking the wings, top, bottom, leading edges for cleanliness, for damage. You're inspecting the spoilers or dive brakes, making sure they're mechanically sound, free of any obstructions, and that the controls are working properly. You check the wing tips and any skids or wheels for general condition. The ailerons are next, making sure they move freely, their hinges and connections are secure, the gap seals are in place, and that they're responding correctly to the control stick. If your glider has flaps, you check those for damage, range of motion, and control continuity. Don't forget the empennage, the tail section. Check that for any signs of damage. And you got to make sure the static ports, pitot tube, and total energy probe are clear of any obstructions. Then you move on to the tailplane, top, bottom, leading edges again, looking for cleanliness and damage. The landing gear gets a thorough inspection too.
Oh, right, because landing gear issues, they can be a real problem in gliders, especially the training gliders.
Yeah. So you're looking for damage, wear, and you're checking the condition of the brake pads if you can see them, or do a brake check by physically pulling the glider. Finally, you inspect the elevator and its trim tab connections, freedom of movement, gap seals, control continuity, and then do the same for the rudder. Literally every single part of the glider gets scrutinized.
It's really about leaving no stone unturned.
It is. It's about being as thorough as you can possibly be. And even after that incredibly detailed pre-flight walk-around, there's still more. You've got the pre-launch checklist to go through once you're strapped into the cockpit.
And there's some generic ones you can use if your POH doesn't have a specific one, right?
That's right. And one of the things I really like about the pre-launch checklist is the emphasis on positive control checks.
What exactly does that involve?
So with the help of a crew member, you physically move the controls, and they observe each surface: ailerons, elevator, spoilers, flaps, rudder. And you're not just looking to see if they move, you're feeling for the correct resistance. If a control moves too easily, and there's not that resistance on the corresponding surface, it means there could be an unsecured connection.
And that's a huge red flag.
Absolutely. That glider is not safe to fly. And then there are those procedural checks inside the cockpit. You mentioned CB Swift, CBE, and ABC, CCCDDE.
Yeah, those acronyms, they kind of threw me at first, but when you break them down, they make a lot of sense.
Yeah, they're just mnemonics to help you remember all the essential items. So you're checking your altimeter, your ballast, making sure your seatbelts and shoulder harnesses are secure, double-checking the controls, the canopy, the tow cable connection, the dive brakes, noting the wind direction, and reviewing the emergency plan.
It's about having a structured, systematic approach to those final checks.
Exactly. Nothing gets overlooked. Okay, so we've covered a lot of ground here.
Yeah.
But before we wrap up, we need to talk a little bit about glider care, about keeping these aircraft clean and in good condition.
Because that's an important part of safety too, right?
Oh, absolutely. A clean glider is a happy glider. And it's not just about aesthetics. It's about being able to spot any potential issues early on. A good habit is to wipe down the glider after each flight, just with a soft cloth or a damp chamois to remove any debris, bugs, anything like that, before it has a chance to dry and bake on.
And the cleaning methods, they can vary quite a bit depending on the type of glider you have, right?
Yeah. For fabric-covered gliders, you've got specialized cleaning products designed for aircraft fabric. And you need to be a bit more careful with water, especially on older gliders because it can cause damage. Metal gliders, they're a bit more robust. You can usually clean them with a low-pressure hose and some mild detergent.
But no pressure washers, right?
No pressure washers. You don't want to damage anything. Now, high-performance fiberglass gliders, they often benefit from special cleaning sprays or pastes. But you got to be really careful with powered buffers. If you use them improperly, you can actually damage the fiberglass.
So it's best to err on the side of caution there.
Absolutely. And for the canopy, always use cleaners that are specifically recommended for aircraft canopies. You don't want to scratch it or cloud it up. Now, after you've cleaned the glider, it's also a good idea to apply a wax or a sealant to protect those surfaces from the elements.
But I heard there are some caveats with waxes, especially on fiberglass gliders.
Yeah, you want to avoid silicon-based waxes on fiberglass. They can actually interfere with repairs if you ever need them. And the application process, it's pretty straightforward. You apply the wax or sealant, wipe off any excess, and then buff it by hand with a clean cloth. And while we're talking about maintenance, it's worth mentioning that pilots can actually perform certain types of preventative maintenance themselves.
Really? So you don't always need to take it to a certified mechanic?
For certain things, no. Like if you need to replace a wheel or something like that, you can often do that yourself. But there are limitations, of course. Anything that involves complex assembly or structural repairs, that needs to be done by a certified mechanic.
So where do you find out what you're allowed to do yourself?
Appendix A of 14 CFR Part 43. It's available online at www.ecfr.gov, and it lists all the maintenance activities that a pilot is permitted to perform. It's a good resource to have on hand.
So let's bring it all together. We've covered a lot of ground here, literally and figuratively.
We have.
Assembly, storage, trailering, tying down, ground handling, inspecting the launch equipment, those incredibly detailed pre-flight and pre-launch checks, and even some basic glider care and preventative maintenance.
And I think the overarching theme here, the one that really stands out from all of your sources, is the importance of that GFMPOH, the Glider Flight Manual, or Pilot's Operating Handbook.
It's the Bible for your glider.
It is. It's the definitive source of information. It's specific to your glider model, and it lays out all the procedures and specifications you need to follow. You got to know that document inside and out.
Yeah, that seems to be the consistent message here. Know your POH, follow the procedures, don't cut corners. And you know, what really strikes me after this deep dive is how meticulous the whole process is. Every single step, from the moment you take that glider out of storage to the moment it leaves the ground, it's all about being thorough, paying attention to detail, anticipating potential problems before they happen.
And that mindset, that approach to risk management, it's not just applicable to gliding, right?
Exactly. I mean, think about it. In our own lives, in our work, in our relationships, how often do we cut corners? How often do we rush through things, assuming everything will be fine? And then when something does go wrong, we're surprised. But with gliding, there's no room for that kind of complacency. It forces you to be deliberate, to be systematic, to think ahead.
That's a valuable lesson, isn't it?
Absolutely. It's about recognizing that even the smallest details can have huge consequences, and that taking that extra time to do things right, to double check, to follow the procedures, it can make all the difference. So as you go about your day, your week, think about the areas where that level of attention to detail, that meticulousness, might be beneficial. Where could you implement a more thorough, checklist-driven approach to minimize risks and improve outcomes? It's something to consider. Thanks for joining us on this fascinating deep dive into the world of safe glider operations. Until next time, stay curious and keep exploring.